Okay, so let's look at your questions on page 377, 378. I asked you to do 9 to 12. So the number 9 says, an object is 20 centimeters in front, so that's going to be DO, 20 centimeters, in front of a convex mirror with a focal length of negative 15 centimeters. They are way nicer than me. I will not always give you the negative. I'll tell you it's a convex mirror, and I'll tell you the focal length, but I'll be checking to see, do you know that always when it's a convex mirror that it's negative? Find the location of the image using a ray diagram and using the mirror equation. So first with the ray diagram, F is back here, C is back here, and DO is up here, okay, 20 centimeters. Take a ray straight in from the top, going parallel to the principal axis. It's going to get reflected in such a way that it appears to be coming from F on the other side of the mirror. A ray that looks like it's going to go in through C will get reflected back along itself. Of course, I don't have a hand to hold this. So on this side, it's going to be broken because it's not really going here. And then here, it's going to be solid. Oops, and that was what I was worried was going to happen. Okay, so going in through C, getting reflected back through C. Same for the bottom. In parallel, I will draw freehand. In parallel to the principal axis. Getting reflected in such a way that it looks like it's coming from F. Okay. And then in through C, looking as if it would go through C, it'll get reflected back right on itself. Again, this side will be broken because it's not really here. This side will be solid. Okay, and where will the image be? Where the blue cross, that's the head. Where the purple cross, that's the feet. Here's the little guy. He's not very big. And then they want you to also find it using the mirror equation. So 1 over F is equal to 1 over DO plus 1 over DI. 1 over DI is equal to 1 over F minus 1 over DO. So that's equal to 1 over negative 15 centimeters minus 1 over 20 centimeters. Common denominator is 60. So 1 over DI is equal to negative 4 over 60 centimeters minus 3 over 60 centimeters, which is equal to negative 7 over 60 centimeters. So DI is equal to negative 60 centimeters over 7. So DI is equal to negative 8.57 centimeters, where this negative means virtual. Okay. Turn the page, number 10. A convex mirror has a focal length of negative 12 centimeters. A light bulb with a diameter of 6 centimeters is placed 60 centimeters in front of the mirror. So the 60 centimeters in front of the mirror is the DO, and the 6 centimeters is the HO. Where is the image? Okay, so you're looking for DI. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over DI is equal to 1 over F minus 1 over DO. 1 over negative 12 minus 1 over 60. Common denominator is 60. So 1 over di is equal to negative 5 over 60 minus 1 over 60, which should be about negative 6 over 60. di is equal to negative 10 centimeters, where again the negative means virtual. Okay, my bet is the second part of the question wants to know how big the image is. What is the diameter of the image? So you're looking for hi, so hi over ho equals negative di over do, using the textbook's equation for with the negative. So hi is equal to negative di ho over do. So negative times 6 centimeters over 60 centimeters. So you get a positive 1 centimeter. So the image is 1 centimeter tall. Number 11 says, in a department store, a mirror used to watch shoplifters has a focal length of negative 40. So again, it must be a convex mirror. Locate a person stands in an aisle 6 meters. DO is 6 meters. From the mirror, locate the person's image using the mirror equation. Is it erect, virtual, smaller, larger, etc.? So 1 over f is equal to 1 over do plus 1 over di. 1 over di equals 1 over f minus 1 over do. Notice you have centimeters and meters here. I would probably change to centimeters. So 1 over negative 40 centimeters minus 1 over 600 centimeters. Okay, so you could 40, 60, common denominator I think is 600. So 1 over di is equal to negative 15 over 600 minus 1 over 600. So negative 16 over 600, which means di is equal to 600 centimeters over 16. Of course, you don't leave it that way. You end up dividing and getting negative, whoops, lost the negative there somewhere, negative 37.5 centimeters, where the negative means virtual. It asks, is it bigger, is it smaller, is it erect? Well, it's virtual, so it's definitely erect. And this is the only case for the convex mirror, and it's always, always, always tinier. All right, number 12 says, convex mirror is needed to produce an image located 24 centimeters behind the lens. So your DI, or behind the mirror, negative 24 centimeters. That is 3/4 the size of the object. That's M, the magnification. What is the focal length? So the first step is to find DO. So you know magnification is equal to negative DI over DO. So DO is equal to negative DI over M. So DO equals negative 24 centimeters divided by 3/4, flip and multiply. DO is equal to 32, I believe, or 18, flip. 4 over 3, 8, I think I get 32 centimeters. So then you go 1 over F is equal to 1 over DO plus 1 over DI, and we're looking for F, so 1 over F is equal to 1 over 32 centimeters plus 1 over negative 24, common denominator 96, so 3 over 96 minus 4 over 96 should equal negative 1 over 96. So the F should equal negative 96 centimeters, and this means it's a convex mirror. Okay, that is the 4 questions in the first set. Convex mirror, so it also means the F, of course, is virtual because it's behind the mirror, since I had another 3 seconds before the video ended.